Hi Geo H, this is Unit 5, Lesson 6, and today we're going to do a review of the Pythagorean Theorem. So this is something that you learned back in 7th grade, rather. And the Pythagorean Theorem is used only in a right triangle, and it's used to find the missing side of a right triangle. So if we're looking at our picture right here, okay, I have this nice right triangle, and I'm calling the sides A, B, and C. So A and B are called the legs of the right triangle, and C is called the hypotenuse because it is across from the right angle. So that's important that C is the hypotenuse. Now the relationship between those legs and the hypotenuse is that A squared plus B squared equals C squared. So the A and the B don't really matter because I'm just going to be adding them. So those are the legs. They can go in either order. But the hypotenuse, which is across from the right angle, is the side that's by itself. And again, this is used to find the missing side of a right triangle. So let's look right here. An example 1A. The side I'm missing is the hypotenuse, so that's my C. 5 squared plus 12 squared equals C squared. A squared plus B squared equals C squared. 5 squared is 25. 12 squared is 144. 25 and 144 is 169. And then I take the square root of that, so my missing side is 13. And this is a combination that comes up a lot, 5, 12, 13. All right, and B, I'm missing one of the legs. So that could be my A or B, it doesn't really matter. 12 squared plus B squared equals 20 squared. The important part is the hypotenuse, and the hypotenuse is across from the right angle, and that's the side that's by itself. 12 squared is 144. 20 squared is 400. I'm going to subtract 144 from 400, and I get 256. And then to get B by itself, I have to take the square root of 256, which is 16. All right. So because solving the sides of a right triangle involves finding the square root of a number, the answers are sometimes going to be an irrational number or a non-perfect square. These here were perfect squares, so those were nice and easy to do. If it's not a perfect square, we're sometimes going to have to simplify the radical, or sometimes they'll just ask us to find it to the nearest tenth. So we're going to do a little bit of both of that in example 2. So I'm missing my hypotenuse, that's my C. So 5 squared plus 5 squared equals C squared. 25 plus 25 equals C squared. 25 plus 25 is 50. Okay, and then I'm taking the square root of 50. Now this is not a perfect square. So what I do is I have to break it down. I say what times what is 50. And one of the numbers has to be a perfect square. Now, what do I mean by perfect squares? These are my perfect squares. I'll list them right here. Square root of 4 is a perfect square. It equals 2. Square root of 9 is a perfect square. It equals 3. Square root of 16 is a perfect square. It equals 4. Square root of 25 is a perfect square. It equals 5. So these are my perfect squares right here. So what I'm doing is I need to break it down into a perfect square and then another number that's not a perfect square. I'm just going to finish my list right here. Those are my perfect squares. So I'm saying to myself, what times what is 50? And one of the numbers needs to be a perfect square. Well, 25 times 2 is 50. And 25 is a perfect square. So that gets written first because that number is actually going to get simplified. The square root of 25 is 5. And then radical 2 just stays radical 2. So that is the answer. Now, they also wanted me to find this to the nearest tenth. So I'm just going to do radical 50 in my calculator, and radical 50 in the calculator is equal to 7.3. So those are my two answers right there. All right, let's try another one that I'm going to have to simplify. So again, I'm missing my B. So 4 squared plus B squared equals 8 squared. 4 squared is 16. 8 squared is 64. I'm going to subtract 16 from 64 and I get 48. So B is the square root of 48. So I'm saying to myself, what times what is 48? And one of the numbers needs to be a perfect square. That's the only way to simplify this. 16 times 3 is 48. The 16 gets written first because that's what's getting simplified. And the square root of 16 is 4. And that's my answer. And 3 stays radical 3. And then in my calculator, I'll do square root of 48. And that equals 6.9 if I'm rounding it to the nearest tenth. Okay? Now, these are also some real-life kinds of problems that we have with Pythagorean Theorem. So if we look on the next page, I have a 12-foot long ladder. So the ladder is the thing that's leaning right here against the building. All right, that's my hypotenuse, and that's 12 feet. It's leaning against a wall such that the base is 4 feet from the bottom of the wall. The picture's here, but sometimes you're going to have to draw your own picture. So basically, this side right here is 4. And then I want to know how high up the wall does the ladder reach. This is my x right here, or my b. So I'm using the Pythagorean theorem. 4 squared plus b squared equals 12 squared. The hypotenuse needs to be by itself. That's my c. 4 squared is 16. 12 squared is 144. Then I'm trying to solve for b, so I'm going to subtract 16 and I get 128. So b squared is 128, and b is the square root of 128. And the square root of 128, I just want to find it to the nearest tenth, so I don't need to worry about doing it by simplifying it. I just do it right in my calculator, so that's the easiest thing to do. It's 11.3 feet high. All right. Question 13, I have an equilateral triangle. So that means all sides are equal to each other. So all these sides are 10. And I have, what is the area of the triangle in simplest radical form? All right, so the problem is, in order to find the area of a triangle, I need to know what the height is, because my formula for area of a triangle is half base times height. Now I have the base. The base is 10. The problem is I don't have the height. I'm missing the height. So I need to figure out what that height is. Now, when I draw the height of an equilateral triangle, it actually cuts the base in half. So this right here is 5, okay? And I don't know the height right here, which is h. But the height is perpendicular to the base, so I can just use the Pythagorean theorem to figure out what that height should be. And I'll do that right here. So 5 squared plus h squared equals 10 squared. 5 squared is 25. 10 squared is 100. I'm going to subtract 25 and I'll get 75. So my height is the square root of 75. And I want it in simplest radical form. So I have to break down that 75. I say what times what is 75. 25 times 3 is 75. The 25 is my perfect square. And the square root of 25 is 5. And the square root of 3 stays square root of 3. But this right here is my height. And that's going to go all the way over here. My height is 5 radical 3. So 1/2 times 10 is 5, and 5 times 5 is 25 radical 3. And that is the area of that triangle. Okay, so you can see how I can use Pythagorean theorem in a problem to find area. All right, and the last one that we have, line segment AB is shown on the graph. It has endpoints of -2, 4, and B is 6, 2. We would like to find the length of AB. So on the graph, I'm going to actually enclose this in a right triangle, okay, just like that. So you do the same on your paper. So I'm creating a right triangle, and I can find the length of those horizontal and vertical lines that I just drew. I can't find the length of AB because AB is a diagonal line. It's not horizontal and it's not vertical. I can't just count it. But what I do is I make a right triangle. I can count the length of this base right here, 1, 2, 3, 4, 5, 6, 7, 8. And I can count the height, 1, 2, 3, 4, 5, 6. And then I'm just going to use the Pythagorean Theorem. This is all I have right here. I have this lovely right triangle, and I use the Pythagorean Theorem to find that missing side. So 6 squared plus 8 squared equals c squared, because c, or AB, is my hypotenuse. 36 plus 64 equals c squared. 36 plus 64 is 100. So c is the square root of 100. C is 10. Okay, so AB is 10. So I use the Pythagorean Theorem to find the length of AB. Okay, and what we're going to do tomorrow is we're going to use the distance formula, which comes from the Pythagorean Theorem, to find the length of line segments. So we'll practice Pythagorean Theorem tomorrow.